Hi, welcome to another session of Circuits and Networks. In today's class 4 under Basics of Electrical Circuits and Networks, we are going to see the basics which are involved with KVL and KCL and how to solve the problem if at all current, voltage or power is asked at a particular branch or a terminal. So we'll start off with this first problem. Here you can see a pentagon is given where you need to find out all the branch currents and voltage across DE branch. So DE branch I have named here as D and E. Okay, so we need to find out the voltage across this. So how to solve this kind of problem? So for that, let us assume that the current flowing through AB is I ampere. You can see here different conditions of node currents are given and the branch resistors are given, and we have just framed A, B, C, D, E as node voltages. So if at all we assume the current which is flowing through branch AB as I, then what is going to happen to the next of the branches? Then naturally, if at all I take the current direction in counterclockwise direction, then IBC, that is the branch current BC would be, you can see here, you apply a KCL at this node B where the input current is I ampere, another input current is 12 ampere, the output current which is flowing through IBC, it would be I plus 12 amperes. I hope you understood how we frame the branch current IBC. The same logic will apply for branch current ICD, which is nothing but equal to the existing current was I plus 12 and the outgoing current I'm treating as a negative, so that is minus 21 amperes. So incoming we are treating as positive, outgoing we are treating as negative. Fine. If that is true, the value of branch current ICD would be I minus 9 amperes. The same logic will apply for the branch current IDE over here, which is nothing but I minus 9, the previous current, plus 23 amperes, which is incoming. So the net value of IDE would be I plus 14 amperes. And the next branch current, that is IEA, where you have node E, the input currents are 17 amperes and just IDE is the input current, where the output current would be IAE or IEA, and that IEA value is nothing but the previous branch current, that is I plus 14, and incoming is 17, we are treating as positive, so the net value would be I plus 31 amperes. So you have 5 branches, and so we framed 5 branch currents like this. Okay, now our intention is to find out the value of current I. For that, let us apply KVL to the closed loop A, B, C, D, E and A in counterclockwise direction, assuming that the potential of A to be at higher. With that, I'll be framing the resistance with current as a drop, and this equation is framed where you have algebraic sum of the voltages in a closed mesh or loop is equal to 0. With that, the like terms on one side and the unlike terms on another side, you can see we can get the value of I, which is nothing but equivalent to minus 10 amperes. And thus we have find out the value of current I. But our intention is to find out the branch currents, right? So I'll take this minus 10 amperes and I have these equations IA, IB, IC, ID, IE. In that I'm going to substitute the value of minus 10 amperes. With that, I'm going to get the value of IAB as minus 10 amperes. Then IBC would be minus 10 plus 12, that is 2 amperes. Then ICD, it would be minus 19 amperes. Again IDE, it will be 4 amperes. And finally IEA, which will be equal to 21 amperes. So these are the branch currents what we have obtained by applying node analysis as well as mesh analysis, that is KCL and KVL. And another thing is that we need to find out the voltage across branch DE. So we have a resistance 0.1 ohm. You have to multiply resistance with the branch current IDE. So IDE is nothing but 4 amperes and the resistance is 0.1 ohm. With that, I'm going to get the value of voltage as 0.4 volts. So this is how you need to solve this kind of problems. It's a basics of circuits and networks. In order to cross-check our result, you just apply KVL in anti-clockwise direction and you have to get the sum of the voltages which should be equivalent to 0. You can comment in the chat box whether you got the value of voltage drops in a loop is equal to 0 or not. We'll go with the next problem where you can see here randomly the values of current, voltage are given and we need to find out the value of unknown resistance which is shown here as R. For that, what is the given data? The given data is voltage drop across 8 ohm is 40 volts. So here you have 8 ohms and the drop here indicated as 40 volts with polarity. You can see positive is on lower side and negative is on upper side. Fine. So let X be the current flowing through 8 ohms. I have taken the direction of current of X in this direction and that information, that is the voltage across 8 ohms is nothing but 40 volts. With that, I'm going to get the value of current, that is the current X, which is nothing but 40 by 8, which is 5 amperes. So I have obtained the value of current, that is X, that is the branch current, which is the continuous from this node to this node. To identify the node, apply a node voltage V and calculate current Y. So here you can see I have taken a current Y in this direction and a node voltage over particular node as V. Then the incoming current is 15 amperes and X and the outgoing current is Y. So with clear inspection, you can get the value of current Y, which is nothing but equivalent to, that is 15 plus 5 equal to 20 amperes. Just applying KCL at this particular node, that is stated as at particular node the incoming current is equal to the outgoing current. With that, you're going to get the value of current Y, which is equal to 20 amperes. Fine. Once we are done with this current, let us apply loop analysis, that is the KVL, to this particular closed circuit in clockwise direction. For that, I'll start with this minus 120, that is the given voltage source, plus 40, that is the voltage across 8 ohms, plus 2 into 20. 2 is the resistance and 20 is the value of current Y, plus R into 5. Why this 5? You can see the 5 amperes is the value of current that is in X branch and the X branch is continuous from this node to this node. So R into 5 equal to 0. With that, we can get the value of resistance, which is equal to 8 ohms. So this is how you solve this kind of typical circuits. Based upon this concept, recently in GATE 2025, for 1 mark, they have asked us to calculate the value of node voltage X. You can see here over here, you have 9 volts, you have 8 volts, 2 ohms is in series with 1 ohm and 3 ohms is connected over this particular node. In these 3 ohms, 9 volts is the supply and 1 ampere is the current flowing. And on the other part of the circuit, you can see the dashes are shown, which indicates that the circuit is continuous and in fact this particular part of the network is not connected in proper. So what is the question? Question is asked us to calculate the node voltage at X. For that, what we are going to do, we'll ignore this, the what do we say, the resistors which are shown by dotted lines. What is our intention is to calculate the voltage at X. For that, let us calculate the voltage across 3 ohms. Since we have 3 ohms in which the current 1 ampere is flowing. With that, I'll get the value of voltage across 3 ohms as 3 volts. Fine. So let me estimate a node Y over here. So I have 9 volts as supply from the top, and I have 3 volts which is flowing in this particular branch. So the net voltage across Y, it will be 9 minus 3, which is nothing but 6 volts. So I'm done with the voltage across this particular node. So on the left side of this node Y, I have X and 8 volts. If at all I ignore this X for instance, I have 3 ohm resistor, that is 2 in series with 1. On the left I have 8, on the right I have the node voltage as 6 volts. With that, I'm going to get the value of current which is flowing in 2 ohms or in 1 ohm or in the combination of series 2 plus 1, that is 3 ohms. It will be 8 minus 6 by 3. So it is nothing but 2 by 3 amperes. So once I'm done with this current, it is easy for me to estimate the drop across 2 ohms as well as 1. Therefore, the voltage developed in 2 ohms, that is the value of resistance multiplied with this current 2 by 3 amperes, it would be 4 by 3 volts. Now from the starting we have seen how we have estimated the value of voltage across Y. Same analysis we are going to apply across X. So therefore the voltage at node X will be 8 volts minus the recent voltage what we have calculated, that is 4 by 3, which is equal to 20 by 3 volts. So these type of questions are frequently asked as basics of circuits and networks under competitive exams. You can cross check the result by assuming X and Y as the node voltages and comment in the chat box whether you got the same answer, that is 20 by 3 volts or not. In the next problem, we need to calculate the power dissipated in 12 ohms and 40 ohms. So this is the circuit given to us. Now you see, actually it's a 3-loop circuit. In fact, 10 and 40 are in parallel, 6 and 12 are in parallel. So if at all I go for the quick solution, I have 15 volts as a source voltage. The combination of 12 parallel to 6 gives us the value as 4 ohms, and 10 with 40 will give you the value as 8 ohms. So for this, if at all I calculate the current which is flowing from the source voltage in clockwise direction, I'm going to get as 1.25 amperes. Okay, but our intention is to calculate the power dissipated in 12 ohms and 40 ohms. For that, apart from this mesh analysis approach, let us go for the node analysis approach, where the unknown voltage is V over this particular node. You can see over here the known voltage is 15 volts. So what I'm going to do, I'll take this node voltage as higher potential, and the branches which are connected to this node, that is 4 branches are connected, and a potential 15 volts is also connected, which is having a supply to this particular node through 12 ohm and 6 ohms. So let me apply KCL at this particular node V. So I'll get V minus 15 by 6, that is a current, branch current, and V minus 15 by 12, another branch current which is connected to this node V on the left hand side, plus V by 10, V by 40. So taking the like terms on one side and unlike terms on another side, I'm going to get the value of V as 10 volts. So once I'm done with this V equal to 10 volts, let me cross check whether to the initial approach what I have applied over this particular mesh, which is of single loop. In that, if at all I apply a node voltage V like this, it is quite similar to this particular circuit. So I'm going to get V minus 15 by 4 as one branch current. Another branch current is V by 8, which is equal to 0. Here also I'm going to get the value of voltage as 10 volts. So this is the important observation what you have to look into the circuits when you calculate the node voltages. Fine. In both the cases we got the value of voltage as 10 volts. Now let us calculate the current in 12 ohms which is nothing but over here. So here you can see, here you have left 15, on right you have 10. So difference of voltage is 5. So I12 will be nothing but voltage in parallel remains the same. So 5 by 12 will give you the value of current as 0.416 amperes, and the power dissipated in this particular resistance, it would be 2.08 watts. Now you see over here, we need to calculate the power in 40 ohms. For that, current in 40 is nothing but the voltage across 40, okay, and the applied value of voltage, that is the calculated, in fact the value is 10, so the value would be 0.25 amperes. When you multiply this current, okay, and calculate the value of voltage, you are going to get the value of power, that is nothing but equal to 2.5 watts. So this is how you need to calculate the power calculations, current calculations, and voltage calculations. So that's enough for today's class. I hope you like this particular session. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications.